Hello, everybody.
Good evening, Professor.
Good evening, Professor.
Hello.
Good evening.
Hi. Do you mind to turn up your camera?
Professor, it takes me 5 minutes. Just I'm setting up my system.
That's totally fine. I just want to make sure I can recognize your face.
Yeah. Just it takes 5 minutes.
No worries.
Yeah.
Take your time.
Thank you, Professor.
Yeah. We actually prefer you to turn up your camera so I know who you are, and we can have more face-to-face interaction. So make sure that you turn up. It's okay if you need to step out a little bit, turn off your camera for emergency. But yeah, I just prefer you turn up during the entire course. Okay. So we're just gonna give a couple more minutes. I see that we have 8 students here. I believe we have 4 more. So let's give a couple more minutes and then we'll start. Okay?
Okay, Professor.
Yep. All right, I think we can start now. I expect to have a couple more students join, but that's okay. I think we can start now. This is our first week of the class, and I'm your professor for this class. I'm David Jing, Professor Jing. So this is the first time I meet you guys. So I read your self-introductory on the discussion board. I know a little bit about you, but I'm trying to match the face to you all. So I'm just try to see. I think we have. Can you guys all turn up your camera so I can recognize your face? And so today we're just gonna give you a little bit of intro about the class, and I'm gonna let me share some my screen. So I have an agenda here, so I just want to go over that. Let me start sharing my screen. Give me 1 second. Let's see. All right. Can you all see my screen? Yes. Can you see?
Yes, Professor.
Okay.
Yeah, we can see.
All right. All right. So this is the agenda for today, right? So first, I would like to give like a quick intro about myself, and also I want to give the chance to each of you, and also give a quick intro about yourself, let your classmate know about you. So that's the first thing, and then we're going to go over the course requirements. So we'll go over some, the syllabus, the things on the syllabus, and also the homework, the labs, when you have to do hand them in, and also if you have any questions about the syllabus, I want to take the opportunity to answer them here. And then we're going to talk about the article. So for each week, you're required to read some articles, right? I believe you guys all read it, the first two, right? Any of you did not read the article? It's okay if you didn't read it, but I expect you to read them, and so I will go over those articles, and then there's some key concepts I do want you to know them. I want to review them, and if you can, take some notes, that would be great, because later when you do your homework, when you do your labs, you would definitely need them. So, and then last, we're going to talk about the papers, right? The final paper, the research paper. So basically, I will give you a data set, or some data, medical data, and you're going to do a research paper, write a research paper, and also give an oral presentation. So I will talk about those 5 items, and at the end, if we have more time, if you have any questions, you can ask me. Does it sound good? Yep. Okay. Let's go to the next page. So a quick introduction about yourself. I know you wrote a lot. I read each one of your response in the discussion board. Very interesting. And I think this is the time to go over this a little bit. And then, so I will start with myself. I have basically 4 questions here. So my name is David Jing, right? And so my hometown is, I came from China. My hometown is Beijing. So I came to this country when I was 18 years old. That's like almost 20 years ago. And then my academic background. So I finished college. My major was in statistics. It was like about 15 years ago. And after that, I worked with a couple of insurance companies. And now I'm working on with CVS Health. So it's an insurance company that provides healthcare insurance, and so and that's basically, I have about more than 10 years of data science experience in the field, in the Medicare field. Actually, that's my specialties. So yeah, so this is actually my first time actually teaching a class, but I do want to use the class here, actually share my experience, share my knowledge about healthcare and healthcare data. So if you have any questions, and just feel free to email me or to to ask me during the class. I'm happy to answer them. Okay. And lastly, so the last question, I think that question is specifically for you guys. For me, I know what I have to do for the rest of my life. I'm in the field, in the healthcare field, so I'm pretty much going forward in the data science track, right? Doing a lot of statistics, build models. That's what I enjoy doing, and that's what I will do for the rest of my life, I believe. So now I want to give the opportunity to you guys. So the most important question here to you is, what do you want to do after you graduate from school, right? Do you have any thought, any idea, any story that you want to share with us? Please welcome to do that, okay? So who wants to start first? Anybody raise hand, or I just call names?
Hi, Professor. This is Bhavani Punna. I'm from India and I'm married. I have a baby boy who's in India. After my I have completed my graduation in Bachelor's of Pharmacy. After that, I have worked as a pharmacist and also as a pharmacovigilance assistant. I have 6+ years of experience as a pharmacist. And to do my education, I came to USA. I'm pursuing my master's in public health right now.
All right. Welcome to the class.
Thank you, Professor.
All right. And who's next? Anybody?
Okay, I'll go next. Am I audible, Professor?
Yes.
Okay. Hi, my name is Prerna Thapa and I'm from Kathmandu, Nepal. I graduated as a BSc nursing graduate from Bangalore, India, but I lived in India, then I moved to United Arab Emirates for job and experiences, where I worked for one of the companies under International SOS. So basically, I was into revenue cycle management, insurance coding, insurance billing, and medical auditing, and all that. And we used to work for American clinics in Afghanistan for US militaries. So yeah, that was one of the very unique experience I've had in terms of my work experience. Um, and about after school, I think I'm kind of liking the whole public health student journey so far, and every semester I get to learn something new. So I would say that I have not decided what I want to go for after graduating, but I think program planning and all those things, I'm really intrigued by that, and I would like to work for like UN someday, maybe like any organization under UN, maybe UNICEF or anything like that, and help make change in health sector.
Oh,
Thank you.
absolutely. That sounds very interesting. I think healthcare or health related professions are great professions. Basically, you can help work with people, with great people, work with very smart people, but also at the same time, you have opportunity to help people, right? I think
Yes.
that's the most important thing, right? Not just work on yourself, but sharing your values with others. I think that's what that's why I choose healthcare or health, even though I don't have much of knowledge into medical part, but I'm data scientist. I know that when I do data, I add more value to the company or to my employer, in which they're going to help people, right? So that's I think that's the thing. So I'm really glad you have some kind of idea about what you want to do. So just keep up all the work and hope your dream become true. Okay.
Thank you, Professor.
All right. So who will be next?
I can go next. My name is Jasmine Bonilla. I'm from East Chicago, Indiana. It's about 45 minutes from Valpo. I just graduated from VU with my Bachelor's of Science in Public Health in May, and right now I'm getting my Master's in Public Health. So I currently work for a medical clinic in Chicago as an evaluation data and coordinator. After I get my master's, I hope to become an epidemiologist in the future. So that's what I'm planning to be.
Wow, sounds very interesting. Epidemiologist. That's a very good profession. They study about disease, all that kind of thing. COVID. They're very, I think epidemiologists, they play a very important role during the COVID period. So yeah, it's a great profession, and welcome to the class. All right, who's next?
I'll go next. Can you hear me?
Yes. Who is
Okay.
this?
My name's Ashley Oakes. My hometown is LaPorte, Indiana. I graduated with my master's in public health in December, and I just recently decided to go the epidemiology track, and so I added it just now. So I'm going for my certification right now. And I just recently I had a job working for VU, and I did like outreach teaching like tobacco education. And I'm hoping to now do the same thing, like what Jasmine said, as be an epidemiologist. That's something that I wanted to do for a long time. And I just didn't really know how to go about it until Valpo added that track. And then I decided that I wanted to continue my education and go for that.
Okay. Yeah, I think if you want to be epidemiology, just your education has to be really good, right? You have to attend years of school, and I think it's just a long journey. But yeah, I'm glad you choose the track and continue working on it. And when I was in my master program, right, I have two masters, one in statistics and one in business MBA, business administration. When I during my masters, I didn't really know what exactly I want to do. I just had some broad idea. But after that, when I look for jobs, right, I immediately realized that data science, they need a lot of data scientists, especially in the healthcare field. So that's why I concentrate myself in the healthcare, learn new knowledge, know more about the industry, and finally I landed on a job. Just knows how to use some of the statistic programs like SPSS, like SAS, like R, those kind of analytic tools. So I think it's really whatever you're doing, you really need to know the knowledge. Really need to have some idea about what you want to do and what you want to be, right? So I think that's important. All right, welcome, Ashley. Who wants to be next?
Hello, Professor. I will go with the next.
All right.
My name is Joshna. I'm from India, and my academic background is I'm a dentist. I and I have a 4-year working experience in India, and I'm doing my master's in public health that focuses on the epidemiology. I would like to become an epidemiologist in the future, as I like the public health field as it focuses on the overall health of an individual.
All right. So it sounds like almost everyone has some kind of a work experience, whether related to healthcare or not, right? So I'm glad that I think during your studies, that will definitely add more values to your studies, and later probably will help you to find new jobs for sure in this country. So, all right, welcome. So who wants to be next?
Hello, Professor. I'll go. Hello?
I don't think yeah, I can hear you now. Yep.
Yeah. Hi, Professor. Myself, Sai. I'm from India. I have done my bachelor's in India back in, 3 years back, and I've been worked as a production officer for 3 years in my country. And as we have got, I got interest in public health because as we have some clinics and hospitals as a family business. So as a part of that, so I need to know more about the health systems and benefits, how the people are treating here, how the whole health department is working, and how it can help our people through this type of technology and knowledge. So that I realized, so I need to take some more knowledge from the outside. So I just decided and just applied for the public health, and I joined the epidemiology.
Okay, welcome.
So thank you, Professor.
All right. So what is your last name? I'm sorry, I think we have two people last.
It's Sai Reddy, Pedi Reddy.
Oh, Penny Reddy. Okay.
It's been too
So,
long. Sorry.
I am taking attendance right here because attendance is
Yeah.
here.
Yeah, we have two Sais, but one she's a lady. I'm a Jenna. It's Sai Reddy, Pedi Reddy.
Okay.
Yeah.
Okay, got you.
Yeah.
Also, at the end, make sure you type your names in the chat so I know you're attending the
Yes.
class. So I have a record because
All right,
yeah.
Professor.
So
I'll do that.
I have students. I'm not really good with names. So
Yeah. I think you'll be good for next class. Yeah.
okay. I'm trying to get familiar with everybody.
Yeah.
Okay.
Yes. Nice to have, Professor.
All right. Cool. So who will be next?
I'll be the
I want
next.
to be next, Professor.
All right. I guess lady first.
Lady first.
Okay, thank you.
All
Good
right.
evening, everyone. My name is Redka Devi Chapa, and I'm from India. I did my bachelor's in biotechnology from Osmania University. During that bachelor's, I did my internship in epidemiology, which focuses on medical coding as well. So I was interested in this epidemiology field, so I did so many research in that. This grabbed my attention, so I just wanted to do my master's in epidemiology. So I came here to pursue my master's in public health, which focuses on the epidemiology. And in the future, I want to do more research in the field of cancer.
All right.
Thank you so much.
So I heard that you say you want to do some research, right?
Yes, Professor.
Okay, got it. Well, the research is another different field. So it does require you to have the knowledge in the domain, right? In the domain knowledge, the experience, the knowledge, as well as you will be able to you need to use some statistic tools like SPSS or SAS or even R. So I suggest you to do some really studies in those fields, learn how to use them. So. Well, welcome to the class.
Thank you, Professor.
All right, who will be next?
I'll be the next professor. Yeah, my name is Tulasi Kota, and I'm from India. I finished my bachelor's in medicine and surgery and worked as a physician in India for 2 years. And when I worked as a physician during COVID times, I felt like something new to be learned from COVID. Epidemiology plays an important role in that, so I chose this public health. After this, I would like to continue as an epidemiologist. That's it, Professor.
All right. Okay, great. Welcome to the class. I think there's a lot of people wants to be epidemiologists here.
Yeah,
so that's great.
Thank you, Professor.
All right. Do we have more, or that's all?
Yeah. My turn, Professor. Can you hear me?
Yes, I can hear you.
Okay. My name is Vladis Altes. I am originally from Haiti, and I went to medical school in the Dominican Republic, which is our neighbor country. And I practiced for 1 year just to get my medical license. I used to be very interested into community health because I used to work with some international organization doing health education in some communities. So because of that, I became very interested into public health. Currently, I'm doing my master's in epidemiology. I'm kind of interested into the whole epidemiology thing. I'm not quite sure what I want to do yet in the future, but I would say epidemiology is my thing. I really like it. And if I could practice as a general epidemiologist, that would also be fine.
All right. Yeah, I think a lot of people enjoy being in this field, right? In the epidemiology field, and wants to learn more about it, and especially enjoy doing it. I think you have to make sure that you enjoy doing your work. So welcome to the class, okay? All right. So do we have more? I think we have.
Yes, Professor.
Hi everyone, this is Sai Suma and I'm from India, and coming to my academic background, I have completed my undergrad from Bachelor's of Pharmacy, and coming to my work experience, I have 2 years as an healthcare analyst and 2 years as a quality auditor, and after the graduation I would like to be a public health educator. Thank you.
Educator. Okay, wow. This is very good. So you want to be a teacher, teaching, sharing your experience and knowledge to the others?
Yes, Professor.
That's awesome. That's awesome. I think it's important so that once you have knowledge, you definitely want to share with everybody. So make sure that everyone that you work with enjoy working with you and also gain knowledge from you and also the experience. I think having long experience in epidemiology field is important. So I think, yeah, welcome to the class.
Thank you, Professor.
And do we have one more?
Yes, Professor. Hello, everyone. So my name is Juweri Sheikh. I'm from India, and my academic background is I have done my bachelor's in pharmacy. I recently graduated, and then I have came to US for my master's in public health, and I want to become a clinical epidemiologist after the school.
Okay, wow. Well, welcome to the class.
Thank you so much, Professor.
I believe that's all. Do we have more? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think we have everybody here, right? All right, great. Now I think I know I can match some of the face with your experience and backgrounds. So this is great. So let's move to the next topic here. So I want to emphasize our meeting time, right? So in the summer, right? In this summer 2 semester, we supposed to have we're supposed to meet 3 times, right? So every other week. So today is our first time to meet, and we will have 2 more meetings. And then while we're not meeting, you still have to do your homeworks, do your readings, and do all the assignment that you need to do, and make sure you understand you spend the time, watch the lecture, and taking notes, and make sure you understand all the concept. Okay, so for this for the next meeting, we're going to also review some key concepts here, right? So and then also I will take the opportunity to answer your questions, and we'll go over some practice problems. So we have some real data that we're going to discuss, and we will probably spend some time to to analyze some data together. And during the final week, right? So we're going to spend some time. So we have final papers and also the oral presentation. So for the oral presentation, so I expect each of the group, right, will spend 20 minutes to talk about your paper, right, your findings, right, all that kind of thing. For each group, you spend 20 minutes, and in total, we have 60 minutes spending on the presentation. Also, we will have, the QA sessions, right? So people may have questions. So I want to spend the time there to go over that. And also at the end, I still want to spend some time to go over the concept, some key concept there, okay? And then, any questions? All right, I take that as no. I know a lot of you taking both classes like biostatistics and health data analysis. Any of you take just one course? Or you all take both courses together? Anyone? Okay, so I know a lot of you guys take both classes, right? So the focus on the classes are different, right? For the biostatistics, so I will go over, basically the principles, right? We'll focus on the principles, concept, explain the ideas there, right? But in the other class, in this class, right? The health data analysis class will focus on the application, right? So we are not going to spend much of time talking about the concept itself, but how to use it, right? So when I say how to use it, for example, like we're going to, later we're going to talk about some statistic distributions. In biostatistics class, I will explain what it is, right? What are the functions? What are the mathematics, backgrounds or ideas behind it? So basically talking about the technical part. And in this class, I will show you how you can calculate the distribution, for example, the accumulation probabilities, right? Here using SPSS. A lot of time, students are focused on, the principal part, right? Wants to know, basically, they don't know how to use them. So in this class, I will show you in SPSS from the data, how you can calculate the probabilities, how you, find out what distribution they are, right? So that's kind of the thing we're trying to do here. So for both classes, they're going to be online, right? So for biostatistics, it's completely online and unsynchronized. And for this class, we're going to have 3 meetings, right? So, and the others, you just need to learn by yourself, on your own pace, right? So you don't have to be here, but, at this time, but you still have to learn by yourself. So for biostatistics class, right? So you have homework, quiz, labs. So you have to make sure that you work on them every week, and make sure you finish them before the deadline. The deadline usually are the midnight of each Sunday. So make sure you submit it before. And also for biostatistics, you have final exam. So the final exam, I believe, is I'm gonna give you like 3 days. I think 3 days. So you can pick a time you can work on it, right? And before the exam, I will definitely spend some time to review the concept with you. So make sure you hit all the points, all the key points, right? And for health, for this class, right, health data analysis, right? So you also have homework and labs, but you don't have quizzes, right? So, but at the end, we will have a paper and presentation. That's something you have to, you definitely want to start early, right? For the final paper, I was planning to collect your paper twice. So I was planning to have like divide the paper into two parts, right? The first part, I wanted you to finish it like after 2 or 3 weeks of, in probably week 3 or week 4. But I did actually talk to some of the students, right? I think it's quite challenging to start writing paper without going off all the concept, all the ideas, right? So all the topics. So I think I have decided to just collect the paper once. So in the last week, right, week 6, so you can just hand me your final paper. So I will talk about the paper in more details, and also the oral presentation, right? The presentation is also it's a group presentation. So you guys need to think about who you want to work with. So I think for this for this class, we have 12 students. I'm thinking for each group, you have 4 students, and we have 3 groups, and each group, right? You will present together, you will write paper together, and you just in the last week, you just give me everything. Okay? Sound good? Any questions?
Yes, Professor. No.
Okay, great. I just want to get some feedback from you. Otherwise, I was thinking maybe I'm talking to unmute or something. All right. So let's talk about the lecture schedules here, right? So the first week, we already had like homework 1 and lab 1 collected, right? So I'm still grading your papers, your homeworks. And for this week, you will have lab 2, right? So lab 2, I expect you to finish your lab by Sunday. And for this week, we're going to talk about the data management, right? Talking about how you clean the data, how you work on the data from data collection all the way till basically prepare the data to a condition where you can use the data to build models. So in this class, right, our focus is on 2 parts. One is data preparations, or data processing. So prepare the data, make sure the data is clean. And then the second part is that we're trying to use the data to do some analysis. When I say to do analysis could be descriptive analysis or predictive analysis. Descriptive analysis, basically, we're looking at the frequency, the mean, the standard deviation, or variance, all that kind of things. We try to describe the data, right? But the second part of it is predictive analysis. So basically, we're using the data to try to make some predictions or try to learn more about the data. So predictive analysis or exploratory analysis, those are based on the model we're going to learn, right? So we're mainly focused on 2 types of models, right? Linear regressions and logistic regressions. So those are 2 big topics we're going to cover in week 4 and 5. And lastly, we're going to talk about survival analysis. So that is, we're not spend too much time on that, but we're definitely gonna go over some concepts, right, and how that related to infectious disease. So that's something we're gonna spend time on. So basically, this is the readings, the assignments, and also the topics that we're gonna cover. And any questions?
No, Professor.
No, Professor.
Okay. If you have any questions, email me at any time, or if you want to talk on Zoom or have a call, let me know. I can make an appointment with you and just talk about those or whatever questions you have. Okay.
Yes, Professor. Okay.
So let's talk about the article. First article is SPSS and what it is. So you guys all read the article and start using SPSS, I believe, right? You already
Yes.
finished your homework, so I think you already started using it. So how do you like it? Do you like it or do you don't like it? Anybody? Any experience? Like, is it hard to use? Is it easy to use? How do you feel about this SPSS software? And first, you have to let me know what it is.
Yes, Professor, it's been a new for me. I mean, it's kind of new for me to use. So I just figured it out by, Googling or asking my, experienced person how to make use of that. Yeah, that's what I got from the article. And
Okay.
I would say it's the same for me. It's the first time that I'm using SPSS, and it requires a lot of thinking to place the thing where it goes. So it's kind of challenging, but we know that we're going to get over it and we're going to do better.
Okay.
Yeah, as Prof said, I too felt the same. Like it's like difficult how to use. Like it's very brand new for me too. So we googled it and we did the steps all to be done in that.
Okay. I like that part about Googling. So every time when you learn softwares, right? There's a lot of resources online, right? You go to Google, you ask questions. There's a lot of tutorials. I mean, a lot of people pick up when they try to learn new things, they get online, ask questions. I think asking questions is very important here, right? So no matter what concept or what even ideas you want to learn or you don't understand, I will always get online, ask questions. So in this case, right, when you learn SPSS, so when I learned SPSS a couple of years ago, I basically pretty much, get on YouTube and just go over all those, tutorials. But I will say here, right, for you guys, right, when you try to learn SPSS or any softwares, so you need to start using it, meaning that you have to spend time on it. A lot of people like try to learn new things, but doesn't want to spend time. I think I would say that's something you don't want to do. You definitely want to spend time and asking questions, right? So some of the advantage of the reason I'm picking SPSS for this class is because there's a lot of advantage of using it, right? First thing I feel is that SPSS is very user friendly, right? So you can when you import data, right, you can it's just a couple button when you click on them, it just import everything for you. It's user friendly. You can drag and you can move icons. You can move reports here and there. It's using it actually works really well. A lot of people can pick it up very quickly, I think. But of course, if this is your first time using software like this, it does require a little bit of time. But once you get used to it, I think you will be more comfortable using it, doing your statistic analysis. And it actually, another advantage is that it does have a lot of extension of statistical capability, right? So it does allow you to do a lot of things like t-test, ANOVA, regression analysis, factor analysis, a lot of things like that. You can easily do them in SPSS without writing any code. So a lot of statistical, software, it does require you to learn certain language. For example, like R. I don't know if you guys heard about R, but R is a very popular, software and programming language that widely used in the healthcare industry. And another one is Python. A lot of people using Python to do statistical analysis. I think both of the languages are very popular, but it does require you to have a lot of like data, like computer science background or knowledge. So for us, right, especially for epidemiologists, we just need to use some kind of tool that is easy to use, right, to do a lot of things that we want to do, right? So SPS is definitely a good tool for that. Okay. And also another plus, something plus about SPSS is the output. So when you produce a report, like you look at the frequency distribution, so you can customize the report to the way that you want to present, right? You can draw the graph, you can plot the data, all that kind of thing. You can easily do them in SPSS. So it's definitely a good software. Yeah, I would definitely recommend SPSS to everyone, even for the future, right? I think this is something you can put on your resume and say you know how to use SPSS. I'm pretty sure that your employee or your potential employer will look at that. That's definitely a big plus for you. Okay, and how do you think about SPSS? Do you feel that is better than Excel or not? I know that pretty much everybody knows how to use Excel here, right?
Yes, Professor.
Any
It's good.
is good, right? Do you think it's better than
Yes.
Excel or worse than Excel?
Yeah, it's better than Excel.
In what way? I mean, when you compare it, you think it's better. What is better? How do you think it's why you think it's better? Can you give me an example?
Like I also used Excel for the same, like for using the data and analyzing the data. Like as you given the example for the patient and all, like both are somewhat same, like Excel and SPSS, but it feels like it we can be do in the one step SPSS.
Absolutely, absolutely. SPS is designed for statistical analysis, right? A lot
Yes.
of time, right, when you do some statistics testings in Excel, first of all, it takes several steps, right? And also it's slow. If you're trying to import some, if you use some big data, for example, if you work on a data that's more than 10,000 records, think about it, how hard it is using Excel to analyze the data, right? And you use a lot of time when you do some complicated, calculation, you have to wait. So it takes a couple minutes or even hours to do analysis in Excel. But in SPSS, it's very powerful, right? So that's definitely some plus there. Okay. I think you all read the article, and I'm glad. Anyone don't like the software SPSS?
Professor, I feel like most of our from medical background, so SPSS is like for me, I think I had lost my friendship with mathematics I mean, sometimes ago. It's been quite a while. So SPSS almost looks like maths because there's no in between. Either the result you get is correct or it is incorrect. So yeah, that part is like I'm feeling like I'm getting into mathematics again. So that can be a little bit challenging, but it's interesting as well. So yeah.
Okay. Yeah, I'm pretty sure, not everybody likes SPSS. There's some better tools there. But yeah, I think it's just as you use more SPSS, I will say you probably will like it. So yeah, all right. Let's talk about the articles that I asked you to read for the second week. So the practical data consideration for modern epidemiology students. You guys read that? Anyone did not read that? It's okay if you didn't read it. I mean, I will go over that. I will go over the key points there, but I just want to know if you have read it. So I have 3 questions here for you. So first question is, they talk about research stages, what they are. Anyone?
Was it data management and analysis?
Yes, data management and analysis. So there are 2 different parts, right? When you get a healthcare data set, so the first thing you have to do is to look at the data, to manage the data management, right? So in the real world, right, the data is not perfect. It came with missings, inconsistencies, and maybe the data is just with bad quality, right? You see some numbers and you think, oh, this number doesn't look right, right? A lot of things like that. In the real world, nobody clean the data for you, and you have to clean the data yourself. So you always need to ask questions, right? So certain things you have to look at, right? So you have to look for outliers. You have to look for missings. The information also you have to look for information that's contradictory, right? It doesn't match to each other, and some things like that. You really have to try to catch them, right? So the second part is the analysis, right? Once you have the data is good, then you can start working on the analysis, right? The analysis itself basically have different parts, right? So the first part, the first thing that you want to look at is the descriptive analysis. So you try to understand what the data is talking about. You try to find you find out the insight, right? So what does the data tells you about? How big is the data, right? What kind of data does it provide you, right? Think about the story. So having a data in front of you, you want to spend time and think about from this data, you want to tell a story. When I say story, is that what does this data tells you, right? So I'm giving you, I did give you this questionnaire, data. What does this questionnaire data tells you, right? So think about that, and you have to do, descriptive analysis first, right? That's all from descriptive analysis. And later on, and you want to make some predictions. Think about it. I'm giving you a case, right? So for example, I'm giving you someone's height, someone's blood pressure, someone's blood sugar level. I'm asking you, is this person, diabetic, right? Does this person have diabetes or not? So using those techniques like linear regression or logistic regressions, basically it will help you to identify who is likely or who is diabetes members, right? Who has diabetes. This is important because when you start, working in this field, right? A lot of time, as an epidemiologist, when you look at data, right, you have to really think. You have to use your knowledge, but also at the same time, you have to clean the data and then make the prediction, right? So this is the techniques or tools that help you to make the prediction, right? Linear regression, logistic regression. We're going to talk about that later. But this is all those steps are in basically in the analysis step, right? So this is two most important stages. So so when you do your research, at the end you have to present your findings, right? Your research findings. So you really need to use those tools to provide evidence. When you say person A has diabetes, person B doesn't, what is the evidence, right? From those tools, it does provide you the evidence, right? So from logistic regression, all those models, fancy models, those are your evidence. So when you present them, you can say from this model, I can tell, person A has diabetes, person B doesn't. So that's basically is something you have to do for your research, okay? So what are the practical considerations? The article mentions 6 of them. Can you name them? Anyone? Or you can pull up the link. Anybody? I sort of mentioned them, right? The missing values.
Like labeling the variables and the data presentation.
There's more, right? Maybe I should pull up that. So actually right here, right? Duplicates, right? Oh, can you all see my screen? Good. Okay,
Yes,
so
Professor.
duplicates. A lot of time that you have duplicates in your data, and you definitely want to remove them. The first thing, right? You check the missing data. You look for the duplicates, and also last, you want to see if there's any consistent or variables that tells the same story. You want to remove them. It is called dimension reduction. But those are the things that you have to be focused when you receive a data from someone. You don't trust them. Often that what you have to do is you need to start thinking about those considerations, right? Practical considerations, missing values, duplication, inconsistency. You have to, for each step, right? You have to check, right? I provide you some tools so you can check the missings, duplication, and inconsistencies. So if you not sure what to do, you definitely want to review my notes, okay? But those are the things that you want to do. And the analysis here, when you look at analysis here, right? We have study design. So when you have a lot of data, you have to think about the design, right? What things, so it's like for your final paper, right? Think about your final paper, right? I want you to look at the data and tell me what you want to learn from this data. You have to come up with your own research topic, right? So that's kind of study design, right? How you want to design this experiment or this analysis, and then so that it can, you can learn from it, so you can do come up with some findings to present, right? So that's the idea. And later we will definitely talk about models, right? Models, specification and assumptions, right? So certain models can only apply for certain with certain data, right? So you have to check for the assumptions first. So maybe after you check the assumptions, the model doesn't. For example, logistic regression. Logistic regression really looking at the data, your data, right? Your dependent variable. So that is the variable that you want to study, right? So it has to be yes or no, or true or false. But your data, if your data doesn't provide you that, you cannot apply logistic regression. So that's kind of the model specification and assumption is about. So you really have to think when you see the data, what kind of model you can use, and whether the model can provide you accurate result. Some model is not good for prediction, making predictions. Other models are probably well, but it creates a lot of bias. When I say bias, is that the predicted value is not the true value, a lot of false or false values in the prediction. So for person, I'm giving you an example, person A, B, C, 3 people, right? Think about if all of them are all diabetic, right? They all have diabetes. But based on your model, you predict them all are non-diabetic. So do you think the model is giving you a good result? No, it's not, right? So basically, if you have 3 people that are all diabetic, and your prediction making them that are not non-diabetic members, right? You predict them based on the data. You say, oh, they're non-diabetic. But in reality, when you see the real data, you see, oh, they are all diabetic. It doesn't give you the right prediction. Then this model means there's something wrong with the model. Maybe it breaks the assumption. So basically, you cannot use this model to make the prediction for your data, and you have to switch to another model, right? Think about using another model to make the prediction or to do your analysis. And also, the last part here is variable selection. So when you think about it, when you get your data that is probably thousands of records, thousands of columns or attributes, right? Thousands of columns. Are you able to use all of them? Maybe not, right? You don't want to use all 1,000 columns, fit them in the model and make prediction. In the real world, there's a lot of cases that you receive the data, the column, probably 2 or 3 columns, they're just measuring the same thing with different names. How do you detect them to know that each column can add more value? So if the columns, if 3 or 4 columns are the same, exactly providing you the exactly same information, then you don't need to put them in all you fit in the model because they're not giving you additional values, right? There's no values added by adding more variables. So you want to reduce the number of variables or reduce number of columns. So you have sufficient columns that you can use to make your predictions. And also number of records. Think about it. You get a data. The data could be very big. Maybe in the data there's millions of records. Probably you don't want to use all millions of records in your model. And you have to use some kind of a sampling techniques, right, to reduce to the number that you're comfortable with, that you can start, build model with, right? So 1,000 million, records, probably in most of the cases, you don't need that, right? And you probably just need probably 500 records, maybe it will work, right? So in that case, you need to think about how you reduce the size of the data set, right? To the size that you're comfortable using them. Also, you think about it, you have your computer, your personal computer may only take up to 1,000 or 10,000 records. If more than that, it will get slow. So that's definitely something you have to think about, how you reduce the variable and reduce the records, right? The number of rows, and to a size that your computer can handle. So that's basically what this article is about. So all those things you have to think about before you start doing analysis, right? So this is kind of the idea I want you to learn from this article. Any thought? Any questions here? Any feedback? Is this article interesting to you? Yes?
Yes, Professor. I think you have covered more points, which makes clear for understanding. Yeah.
Great. So I think this is a very useful article. In the future, maybe this is a really good reference for you in case you don't know where to start with. think about this table, right? Think about what things you need to check, and think about this article and how you start with the data set. And you can, review them before you're doing that if you don't know how to do it. A lot of time when you receive data, you're nervous. You don't know where to start. That's the problem. This table, this article is actually, help you to start your, your analysis, where you need to start, where you need to focus on. So I would suggest you to keep it with you, okay, for your reference.
Okay, Professor.
Okay, Professor.
All right. So let's get back to the. So let's see. We talk about articles. So key concept reviews. So definitely I want to talk about those key concepts. So I see the time now is 7:30. So do you want to, guys, do you want to take a break, or do you like 10-minute break, or do you want to continue until you feel tired? I mean, I'm planning to give you some time to digest what I have just talked about. Do you want to do that?
Yes, Professor.
Okay. So 10 minutes break, this sounds good?
Yeah, yes, Professor.
Okay, we come back about well, let's say 7:45.
Oh, yeah, okay, Professor.
All right. 10 minutes break here.
Yep.
Okay, sounds good. All right. I see you in 10 minutes.
Okay, Professor.
All right. right. Do we have everybody?
Yes, Professor.
Yes, Professor.
Yes,
Okay.
Professor.
Yes, Professor.
Great. So let's talk about some of the, let me see. Let's talk about some of the key concepts here, right? So the first concept that I want to talk about is the structured data, right? So I think you all have worked on structured data before. So basically it's just highly organized quantitative data, right? So the key point here is they can be easily used for statistical analysis. So I was giving you one of the data set here. It's a perfect example of structured data. So let me show that to you right here. So questionnaire data. So if you look at this data, it's a perfect example of structured data. The reason is if you look at this data, right, they're highly organized, right? When I say highly organized, that means it has fixed number of columns. It has a fixed number of rows, right? And it's collecting the same information for all people here, right? So this is a very good example of structured data here, right? So in the real world, when we work on the structured data, right? Some of the tools that are popular to use, one is SPSS is the one we're using, right? The other is what they call SQL, is structured query language. So that language is basically designed for pulling data from the structured data, right? So as I mentioned, right, there's other tools that you can use to pull data, right? Like R, Python, SAS is also another popular tool that widely used in the healthcare industry, and also Stata. A lot of people use Stata as well. But those are the tools that in the future probably you will, if you work in the healthcare field, you will probably need to learn them. But SPSS is definitely a starting point, right? So when you look at the structured data, right? What are the limitations? There, of course, if there's a pros of using structured data, what are the cons using them, right? The structured data, one of the limitation in the real world is that this data was designed for certain purpose, right? So when statistician collect the data, designed to collect data, right? They want to use structured data, and they create this table, and this table is only served for one purpose, right? So this is, as you can see that right here is a questionnaire data. So this table, this data is only used for collecting the questionnaire data, right? So the questions, or maybe the certain attributes about the people who take the survey, right? So basically we have number of columns and number of rows. So in the real world, it's basically when you want to change the structure of the data, it could be very time consuming. So once the design, this data is the structure is set, right? Then we probably don't want to change that, because if you want to adding one more column, it's probably very hard, because other those tables are maybe linked by other tables or other for example website. They have a link to this table, but if you change the structure of this table, of this data, then that link is no longer valid. So think about using the data here, because the data, they're all linked together. It's like a chain, right? If you break one of it, you change the structure of one table, the other table may get affected. So when you try to change the structure, you have to be very careful. So that's one of the limitations. Usually, the data engineer, data people don't want to change the structure. Once they said there's 40 columns in this table, they don't want to change that number. They don't want to change the content. They don't want to add. If they want to add more columns, they prefer to create another table to store the data, but not adding columns here. So that's something I want to point out. So any questions? All right. The next topic I want to talk about is unstructured data, right? Unstructured data is something that basically is not organized. You cannot put in the format that I just showed you, right? You cannot put the data in columns, in rows.
Okay, I found this on the web. It's not organized. You cannot put in the format for format.
Sorry about that. I think my computer is up.
I'm not sure I understand.
Oh. So basically the unstructured data here, right? So we're talking about not predefined data. So basically, think about some of the examples, right? We have images, we have audios, videos, emails. When you work with someone in the healthcare industry, a lot of time that those informations are coming in free text. So for example, like medical records, a lot of the records are even handwritten. So you cannot, a lot of those data are basically unstructured. Nobody actually clean them, find a pattern in them, and put in the tables like structured data. So it's really hard to analyze those unstructured data. So usually they want to convert unstructured data into structured data, into tables and rows. So it's easy for data analysts or data scientists to look at that. So yeah, so a lot of time that you do have to deal with unstructured data, but yeah, just be very careful when you have to work on them. You really have to spend a lot of time doing data cleaning, and also try to do some data engineering work to. Oops. Can you hear me? I'm sorry.
Yes, Professor.
Okay, something just popped up. The Zoom just popped up saying for whatever reason it tried to kick me out. I'm sorry. So basically, good. So let me continue talk about the unstructured data. So unstructured data is something that you have to deal with every day, pretty much. But you do usually, right? As a data scientist or data analyst in the field, in the healthcare field, you definitely need to work with data engineer to processing the data, clean the data for you. But sometimes you have to clean it by yourself. If you don't have a team. So that's something. That's one of the biggest challenge, right? How do you get the clean, structured data? It's not easy as what you think. It's definitely one of barrier you have to think about, or one of the consideration you have to think about. Getting data is very challenging. Okay, any questions there?
No, Professor.
Okay. So let's talk about data quality. When you think about data, when you look at the data set, when you receive a data set, right? How do you know if a data is good or bad? So in the real world, right, the health data is often very dirty, unless someone is there to clean for you, and most likely they are not, and you have to clean yourself. So when you look at them, I would say 80% of the time that you have to, when you get the data, you have to spending on data extraction, cleaning, and transformation, right? So actually doing the data analysis is actually only takes your 20% of your time. So you really have to spend time. I mean, sometimes cleaning data could be very tedious, but you still have to focus in there and work on data, make sure that data is ready to right, for your analysis. So the data processing is very important. Sometimes you have to work on your own. Sometimes you need to work with other people, because cleaning data requires some domain knowledge. You really need to know about the data, and you sometimes, I'm giving you an example, right? Your blood sugar level. So when you see in the data, right, when you see something like your blood sugar level is usually by normal is 5.6, 5.7, but if you see something like -100, you know that, you immediately know that that's not correct. But sometimes, you see something like if the value is like 100 or 200, you must have that sense that that number is not correct. It's not realistic. You have to clean it. You have to do something about it. That's really rely on your domain knowledge. If you don't have that domain knowledge, then you have to ask people. You really have to know the number is the true value. A lot of time that those value can be caused by humans or by computers or by whatever. During the time when the data transfer from one person to another person or to the third person, then there's a chance that data get lost or changed, or either intentionally or unintentionally by whatever. And you have to know, really think about whether the data in your hand is the true value or not. That's something you really have to spend time. So when you look at data quality, right, I'm talking about those 8 areas. You really have to think about accuracy, right? If a good data, when you, I'm sorry. Okay. So when you think about data quality, right, you think about accuracy. The value needs to be the true value. And if it says 5.7, it has to be 5.7 for the blood sugar. Sometimes you see some unreal number, you have to clean it. Either you have to drop the record, or you have to find out the true value about it, right? And the record has to be, the data has to be complete. A lot of time that if the data has a lot of missing values, then it is considered bad data. If it's missing a lot of missing values, if it's just too much, like 80% of the data points are missing, then that data is, you cannot use it. If it's only 50% of it, maybe there's something you can do to save that data that you can use for your analysis. But if you have like 90 or even 100 or close to 100% data missing, then you can't use it, right? And also consistencies. So your data has to be consistent, right? Either, if you have 2 columns, talk about same thing, right? Or similar things. And the information I give you has to be consistent. For example, think about a data set that has a patient birthday. If a patient was born in 1980s and that person is 42, 43 years old, but if you look at the age, right, if that person is, you see the value there is 60, then you know they're not, the value there are not consistent, then you have to check if the birthday is right or the age is right. So you have to do cross validation there, right? Timeness. So basically time. So some of the data is not valid. It's probably only measures certain time, you know, and after that, maybe the value no longer valid. You really have to think about the timeness. Also the credibility, right? Again, that's related to accuracy. So credibility, so you have the full report, you send it to someone or send it to your manager or send it to the clinical teams or whatever teams, right? They have the whatever, you know, data or findings that you present to them or you give it to them, right? It has to be accurate, has to be, they have to build that credibility. They believe in your data. Whatever you find out, whatever your data provide them, they have to trust it. It's a long term, right? It's just not one time you deliver the report. It has to be like series of it, and they build that. They believe in your report, believe in your data, and that data is good data, right? Data has to add values, right? If the data doesn't provide you any additional information to your business, to your whatever, or you know, to your research, then that data is useless. Then it's considered bad data as well because you can't use it, right? Interpretation of the data. So the data has to be interpretable. So it has to be intuitive, something that people can easily read it and understand what you're doing, what data you're collecting, right? It cannot be something that people pulling hair and spend like hours and hours, still doesn't know how to read your data, right? Accessibility of the data as well, right? People are able to access the data, can get the information from your data set. You know, a lot of time that, you know, information can be in the data, but it's really hard to get that information out. So it's not easy. So when you think about good data, it has to be good in those, you know, A domains or A areas. It has to be considered, you know, you have to think about good data. Why people think about, oh, the data you provide is good data, or why is bad? So definitely is one of those areas. If they think is bad, is definitely either it's incompleteness, it's not good, or not consistency, or not timely, something like that. But when you try, of course, it's really hard to be good in all A area, but good data definitely need to be considered, you know, those A areas, A domains, right? You really have to think about them and try to provide good data to other people. If you are just a good provider, data provider, but at the same time, right? If you're just, you know, you get the data and you try to do analysis, and for your analysis, also require good data, right? The data quality has to be good. Otherwise, if you're using bad data or the data doesn't have good quality, then, you know, your analysis won't be valid, or sometimes it doesn't even make sense to do analysis using bad data. Bad data in, bad data out, and that's how you think about that. Okay. So, question for you: when you work on your lab or the questionnaire data, do you think it's a good data or bad data, or any data you think is not good, or any columns that is not good? Anybody? Are you all there?
Yes, Professor.
So the question is, when you work on your first lab, right, the questionnaire, the questionnaire data, right? That do you think it's a good data or bad data? I'm talking about this one right here. Let me share. I'm talking about this data. Do you think it's a good data or bad data?
Personally, I would say it was a good data because I was able to interpret the data, to calculate the amount of people who were single, the amount of people who were widowed, the amount of people who were married. The interpretation of the data helped me understand that it was a good data. This is my opinion.
Okay, but I do see that there's missings. Is it okay to have missings there?
No,
Why not?
that the data accuracy will be wrong compared to the original data set if there are any missing values.
The reason they have missing data is maybe they don't have the information there, or think about it, right? When you try to collect data for each student or each patient here, or well, it's a student, right? So if for each student, right, they're missing, that means you ask questions to the student and the student refuse to answer it. So rather want to give a fake number or give a number 0, they just leave it there. So the data scientist people or data analysts, when they look at this data, then if they try to learn something about this student, right, then they would rather want to use other columns to learn about the student, because those informations are missing. One way to use this data, right, is that you want to do some data imputation, right? So you can make it still use this data, right? But the challenge is that you didn't collect the data from them, this person. You can impute or you can just ignore them. But is it good data? In terms of talking about completeness, this is probably not good data, but this is consider other things, right? Well, you have how many columns you have here? You have a lot of columns here. Think about it. If you're doing analysis that doesn't require you use the cigarette or coffee or soda, then this is considered good data. But if your analysis does require using those 3 columns, then they're considered bad data. But in general, I would say this is probably good data, because most of the data here, you do have values, right? You can see that there's values, but there's some of it that you can probably do something to fix it. But in overall, I would say this is considered good data in general, because you can use it for your analysis, if that makes sense. Sound good?
Yes, Professor.
Okay. Okay. So yeah, so every time you think about the analysis, right? Or your analysis or your data, think about those areas or those domains, right? Let me minimize this. Oops, sorry. Okay. Let me minimize it. That looks good. Okay, next. So we're going to talk about data types. So there's 3 types of data, right? So I mentioned in the lecture, right? So one is record data, another is graph data, right? So, and there's another one. So basically, out of those 3, most important one, the one that you're using a lot or you're gonna see a lot is record data. Because in the healthcare field, right, the data comes to us are often the patient's records, right? So medical records, you know, health records, they're all, you know, record data. So as you can see this one, I'm giving you an example of record data. So the record data here is the diabetes test records, right? So you think about it, each row is a test for diabetes test for the patient, right? So the last column here is diabetes, whether it's positive or negative. The first column is the patient's number or ID, and then those 8 columns here, each of the columns are the information you try to collect from them, right? So basically, those, when you look at this is typical record data that you see. So when you think about it, is each row is either a test or a patient, and then each column here, right in the middle, is the measure that is the information, is the data you collect from each person, and you just collect 8 columns of data, 8 attributes, right? So so that's the number that you collect, and you can, and if you want to add more like information to this, you cannot, because this is record data. You only care about those 8 columns. So this is really typical record data that you're looking at here. But so when you think about this, it's just fixed. You really have to think about it's a fixed set of attributes. Okay. So I'm not going to talk about the other two because the other two are probably not really that commonly used in the healthcare field. But this is the record data is definitely commonly used in the healthcare field. Okay, and talking about incompletion. So there's 3 ways you can fix the record with incompletion. So the easiest way here, right, is remove the records. But there is, situation that you cannot even, remove the record, because think about if you have a small data set, you have a lot of missings. If you remove the records, then you don't have much of the data points left. So that's definitely not a good way to remove the record, right? So, but that is the easiest way. Think about it. If your data set, you have millions of records, maybe you remove thousands of records with missing data is not a problem at all. But that's probably the easiest one you want to do, right? The other one that's often used is fill in with missing data, right? So the data imputation, there's different ways you can do, data imputations. So you can randomly choose values and within a range and then fill in the value. You can definitely do that. Think about the first row here, right? The poverty here, right? The maximum value is probably, if you look at this, is probably 17.3. The minimum value is probably 8.4, right? You can pick a number just randomly from this range and fill in Colorado here and fill in, for Idaho here, right? 2 values here. You can do that. That is one way, but it's not the preferred way to do that. The better way is either you can use mean or median. You calculate the median or the mean of the entire column here, and then try to fill in with these 2 columns here, right? You can also do that. That's probably, it doesn't take time because basically nowadays the computer, the SPSS software can do that for you. It's probably 1 click or 2, a line of code can help you to do that. But there's other ways you can do that. So another one is, you look at the distribution of this entire, well, this is definitely more advanced topic, right? You look at the current distribution of this column, the distribution of this poverty column, and then you just get some sample value from the distribution, right? And then you fill in the value here and there. This is another way, but you have to first look at the distribution of the data here for the poverty, right? And then you decide what to do with the column here or the value here, right? So the last thing is that you can build a model, right? You can build a model to predict the two values here. That's also another, more advanced, technique you can fill in with the value here. But also you can assign some new values like unknown here, or not available, or that you just don't have data there, so you can put a none, or you can default as 0. But in this case, right, it's really unlikely the poverty for Colorado and Idaho are 0, right? For the poverty, the poverty percent, right? So it has to be. If I were take a guess here, it's probably I would say close to some medium or mean. But if you just put 0 here, yeah, you fill the value, but that value is definitely not realistic. Okay. Any questions here? I mean, this is fix the data with incompletion here, right? So basically, when you deal with missing data here, it's the first step you have to do. When you get the data that has a lot of missings, you really have to think about one of the way how to deal with the missing data from here. Any questions? Any thought? Or we're just all sleeping?
No, Professor.
No, Professor.
Yeah, I just want to make sure you're listening. So yeah, so okay. Are we good? All good here?
Yes, Professor.
Okay, so noise. So the data with noise, what is noise? So noise is a problem, noise is always a problem. When you think about noise, let me take you to the previous slide here. So when you look at the data here, all the data value here are real, right? Real data that you just look at them and you don't see any problems. But what if one of the value here is extremely big or extremely small? That will actually have a big impact on your analysis. Think about it. If a value here, for example, for Colorado poverty, the value here is 90%. That is considered a noise, because it's probably, if you calculate the mean and calculate the standard deviation, you try to detect the outlier. And that outlier, that definitely, if you have 90% here, it definitely is right here. If it's definitely an outlier, right? So that will impact your analysis and your findings, and that is called noise. That is one of the examples of noise. So how do you fix the noise? If you have outliers, right, you definitely want to remove them. But sometimes you don't want to just remove them. You want to change the data points to another way. For example, you can do something called binning here. So you think about this diagram right here. You have age, right? But you do have an outlier here, right? Someone who is age 60 or or 60. Well, I wouldn't say it's I wouldn't say it's an extreme value. It's real value. It's just that it's out right here. And you think about that, that could be a noise. It could have impact, but you see that it's probably you do want to remove it or smooth it. When I say smooth it, think about it. You want to do some bendings to make the curve. You look at the distribution of this age, right? And you look at that. You want to see something. When you look at this, you think that this is probably more like a normal distribution because it has this bell curve, right? So when you do some kind of like bending, so it will be more like belled curve. So if you change the bending size, right? So if I'm looking this bending thing, it's probably every 2 or 3 years you bending them, and then you create this histogram, right? But if you change the size of it, or and then it will probably look more like a normal curve, right? So it's like a bell curve. But now if you just use 2, it's just more like it's close to a normal curve, but you do see that there's certain bends that is not fit in this curve. So you do want to change that to have equal frequency, right? So that you have a smoother curve, so it will remove the noise. Or you want to have the noise as small as possible, so it doesn't impact, because noise can impact your findings and your analysis a lot. If you have a lot of noise, some noise basically is the data that influence your analysis. It doesn't add value, but it creates a lot of bumpy. I would say it's like you're riding a car. Noise is like the stone on the road that give you bumpy ride. So you definitely want to remove that, right? So like outliers, you definitely want to remove them. Some suspicious values, you definitely want to check them, check the value. You want to either verify them. Later, you see that the value, it doesn't make sense, or is not right. You probably want to remove that or verify with other people who knows the data and correct the value. So that's kind of like the idea here. Does it make sense? And then the last thing here is inconsistency. So again, you have to think when you look at the data, right? You have to analyze the data and then try to discover the rules and relationship, right? There's definitely, when you look at the data here, there's definitely some violators, right? When you look at that, for example, this one is a perfect example, right? So like a phone number right here. It's starting with area code 150, and you know that this is not a valid, correct area code. So you know this phone number is not correct at all. So you have to validate that. It's the same thing that in the healthcare data, right? A lot of the data, it just doesn't make sense using your domain knowledge. And you have to think about whether you need to remove that, or you have to use some kind of tool to help you to correct it, right? It's just there's a lot of tools you can use to detect the value that is invalid or not correct, right? So next, I just went over some key points here. Any questions? This is just a first, very brief, sort of like an introduction of, data analysis. But you probably in the future or now there's a lot of readings out there. You probably want to spend time on looking them, and also the lectures. Try to think about and also look at some data in the real world and think about, how you can fix those data, and try to think about how those data will help you to do your analysis, like, cleaning data, why you need to clean data, why you need to do a good job in cleaning data. Cleaning data, removing values, detecting the outliers, remove the noise, how does they impact your analysis at the end? So that's something you have to think about. Okay? Any questions?
No, Professor.
No, Professor.
Okay.
Okay. Do we want to have like a 5-10 minute break, or do you want us to continue until the end? It's really up to you. Anyone?
No, we would like to take break, Professor.
Okay, let's take a break. That works. Um,
Thank you, Professor.
all right, let's come back at A37, A38, and then we're going to wrap up. Okay?
Okay, Professor.
All right, great. All right. Do we have everybody here?
Yes, Professor.
Yes, Professor.
Yes,
All
sir.
right. Great. So I'm gonna spend the next 20 minutes talk about your final paper and orientation. I mean presentation, and also I will see if you have any questions at the end. Probably 5 minutes. Quick questions, quick QA, and then we will just wrap up today's lecture. Okay. So, you guys still see my screen?
Yes.
Okay. So talking about your final paper, right? So so basically you have to look at the data set that I provide you. It's gonna be, let me see if I can just show you here. So this data set, let me share right here. So this is the data set I'm gonna provide you for your final paper. So I basically wanted to work on this data set. This is more like a clean data, but it doesn't mean you can skip the data processing step. You still have to do it, but it's more cleaned. So I don't want you to spend too much time on data cleaning, but you do still have to know how to do it. So as you can see, I'm just providing you 8 columns here, right? So from this 8 columns, you probably want to do some
Hello,
data
Professor.
transformation. Yes.
I'm not able to see the shared content.
Okay, let me see if I can share. Can you see it?
Yeah, now I can see.
Great. So this 8 columns, I'm just mentioned, right? So I want you to still do some data cleaning, right? Try to remove some noises, try to check the consistency of the data, and also try to do some data transformation, right? So you still want to do some, outline removal. You still want to, check every single, row, try to see if, or use some techniques we're just talking about and try to detect, some noises and try to see if you want to keep it or drop them. So basically, this is the data set I want you to work on. This is the medical insurance cost. So the last column here, as you can see, is the dollars, right? And then the others is basically give you some, people's, age, or patient's age, sex, and BMI, whether have children or not, whether that person is smoker or not, and where he's come from, maybe the region, is northwest, southwest, all that kind of thing. So this is the data set. By using this data set, I want you to look at this data set and come up with a topic that you want to work on, right? Or the research question. You basically, a lot of people I know, they look at this, it could be they want to work on, look at the smoker, whether the smoker has a higher BMI or lower BMI. How does the two relation, the relation between the two columns, does it mean smoker are more likely to be have higher BMI or obesity, all that kind of thing. So that's one of the area, but there's more than that, whether, smoker impact the charge of insurance, all that kind of thing. So those questions are something that you can start thinking about. Like those are research questions, right? And then maybe you're using your analysis, that the concept, that the tools that you learn from this class, you can just do some data analysis. You have to write a report. So in the report, of course, I want you to state the research topic, give a little bit background, and set your hypothesis, and set your assumptions. What kind of method do you want to use? Do you want a logistic regression? Do you want a linear regression? Do you want to use t-test, ANOVA, those kind of things that tools are out there, and you can do some analysis. And at the end, I want you to create some graphs to demonstrate your findings, and also provide some evidence when you say having a conclusion like females are more likely to have lower BMI, right? If that's your conclusion, you have to provide me the evidence. That you can you do some data analysis, you do some regressions that you learn, right? Whether logistic or survival analysis that you may want to apply here, if that's something that you can think of, right? So yeah, so that's the data set. And let's go back to this slide, right? So I want you to form like a group. So as what I said, right, 4 students in one group. You guys can talk to each other, and then just send me the list of your group members by this Sunday, 5 before the midnight. So if you don't send me the list of your group, or you don't know which group you want to join, at the end, I would just randomly select for you. So so talking about the research paper, right? I decided to collect the paper at the end of the semester, which is week 6. So if you but make sure that start your paper or presentation early. If you have any questions, then you can send email, or you want to have a talk, we can definitely talk. But I don't want you to wait until the last minute and start working on it. Think about this paper requires you to write from 8 to 10 pages with graphs. So I don't want you to cram at the end, but I think so definitely suggest you to start early, at least to start looking at the data first. So that will make your life much easier toward the end. And we just look at the medical insurance data together. And anything else? I will say that's pretty much the final paper and orientation. For the orientation, for the oral presentation, I want you to, of course, that's what I said, right? 20 minutes for each group presentation, and definitely develop 3 questions to ask, right? So at the end, we want you to have 3 questions to ask the audience, and then see if the audience, our students here, can give you the answer or provide you some thought on the questions, or comments, right? Things like that will help you to better understand the data and also better understand the research topics. In your presentation, right, I want you to cover the 5 parts, right? Research questions. I want you to talk about the variables, the measures, what are the variables, and what measures are they continuous, or are they characters, or are they binary, or category variables? What variable are they? And then perform some descriptive analysis. I want to see the frequency, the mean, the mode, max, the quantiles, maybe skewness, is your data skewed or not, things like that, right? Those are the some of the components for the descriptive analysis. And probably you want to do some bivariant or multivariant analysis That is, what are the relation between 2 variables or 3 variables? Are they positively related or negatively related? Why do you want to use one variable over the other variable? Do you want to use all the variables, or do you want to just select 2 or 3 variables? It really depends on your analysis. And at the end, you want to provide some tables and also some graphs to support your findings and your conclusions. Just make sure that you get prepared to answer all the questions from the audience. So that's for your oral presentation. And how do I, grade your final projects? Those are the components, right? So definitely introduction, right? Titles, and there's certain title. It has to, the title or the research question has to be clear stated. You have to describe the questions, state the hypothesis, and why you and for each test you want to state the hypothesis or the question of interest for the question of interest, and you just make sure everything needs to be stated clearly what you're trying to do, right? And then the second part is the data. I want to make sure you can describe the data and then use what method, especially you have to explain what method you use to analyze the data. What statistic, test or what model you choose and why you choose them. You can use one model or you can build more than one model, right? Depends where you want to look. But you have to make sure that you know what you're doing. Not to be just build a model without knowing what you're trying to predict or what you're trying to find what you're trying to analyze, right? And last thing, well, of course, you have to give me some graphs, summarize statistics, right? You have conclusion, you have findings, you have to provide a summary, statistics. What I mean by that, frequency, the count, the percentage of, the distribution, what kind of distribution, or things like that, right? When you use SPSS, there's a set of output that you can get all those informations, and you can just copy the output from the SPSS over to your final paper, and just try to use it as evidence to support your conclusion. That's the third part, and the last part is the discussion and conclusion. I want to make sure that you can come up with questions to ask audience, and audience also need to respond and also answer the question. Make sure that your question is a valid question, is something that you want, there's messages that you want to deliver to the audience, and the audience are convinced by your statistical findings or the number that you present to them. So that's basically is the idea. And so I'm just giving you this rubric, so make sure that you understand the rules that I use to grade your paper, and also grade your oral presentation. So, any questions here?
No, Professor.
Professor, I have a question.
Good.
Yep. Regarding the presentation, yeah, as you mentioned there, yeah, prepare answers. I mean, the questions for the audience. So, do you have any fixed number that we have the 3 or 4 questions, or it's up to us to decide?
I think better to have 3 questions. Minimum to have at least 2 questions to the audience.
Okay, Professor, that's fine.
Yeah,
Thank
yeah.
you.
But if you want to ask more than that, like 4 questions, that's also okay.
Okay.
Yeah.
Okay, Professor.
Yeah.
Yep. Thank you, Professor. Got you.
Try to have 3. Okay.
Okay, Professor. Got you.
Yeah. So I mean, if you in the next couple weeks, if you can think about the research question or you can come up with a research question that you want to share with me, and you can just shoot me an email and let me look at your question. If I think it's a valid question, I can just let you know, and you can just continue working on it. If you want me to take a look of your question first, because I don't want to. I want to make sure that you're on the right track. Your research is not going to be like if the question doesn't really make sense, I will say probably you want to change to something else. But if you want to send me a message saying, hey, this is my research question, can you look at this? I can certainly give you some feedback. So I will definitely remind you probably in week 4.
Okay, Professor.
So yeah, that's definitely something. If you want me to, if you start writing something and you are not really sure whether your analysis or your findings are correct, or you can let me know. Just shoot me an email and definitely give you my feedback, and help you try to finish.
Sure, Professor. Sure, Professor. Thank you.
Okay. Any questions? All right, so I think that's all the questions, all the material I have for today. I will just leave the last 5 minutes to you guys to see if you have any questions. I think now is the good time to ask. Right. If not, I just want to remind you that our next meeting is going to be July 20th at the same time, 6:30 p.m. It's going to be Thursday, and we're going to meet again next Thursday. And if that's all, and I hope you guys have a good evening and happy studying.
Thank you, Professor.
Thank you, Professor.
Thank you, Professor.
All right.
Professor.
Thank you so much, you all.
Thank you, Professor. Meet you next class. Thank you.
All right. Thank you.
Thank you.
Bye-bye.